Good morning, calc fans. How we doing this morning? Little gray day out there, but the weatherman promises that we're going to get a little bit nicer today. It's going to get close to 60 degrees. I hope everything's going well in your family at home, with your family at home. Hope you're staying safe and staying ill-free. Once again, continue to practice your social distancing. The sooner we can get through this, the sooner you can get back to normal classes and we can get back to normalcy, some sort of normalcy again, whatever that new normal is going to look like. Hopefully we can get back to that. So please do continue to listen to the governor and the president and try to get your social distancing, wash your hands a lot, and hopefully we can get back to what we need, normalcy in the classroom here. I miss you guys. I wish you were back in class, and hopefully we can get back to there soon. Yesterday we started talking about the antiderivative. Okay, we'll go through two problems from your homework. The antiderivative, which is also called the indefinite integral. This is the indefinite integral. We have the exponent rule, just like we had with derivatives. We have an exponent rule with respect to the antiderivatives. If we take the antiderivative, ax to the nth dx. Once again, the antiderivative, the integral, is a stretched out s. Okay. We add 1 to our exponent, and we take our new exponent and divide that into our coefficient of a. And then don't forget to get your plus c in there. Okay, because once again, when we do the antiderivative, we're undoing the derivative, and we take the derivative of a constant, that goes away, it goes to 0. Okay, it goes to 0. So we need to be able to place a value in there. We don't know what that value is. We just know it could be a constant. It could be 0 still. Okay, we don't know that. Today, when we start dealing with differential equations, we'll start finding what that c value is. You have two problems in your homework that we'll look at. We have problem number 11, f of x is equal to 3 square root of x minus 2 cube root of x. We need to get it out of the radical form into an exponential form. So we're going to take the antiderivative of 3x to the 1/2 power minus 2x to the 1/3 power. Okay, just taking our radicals and putting it into exponential form. If you remember, we have a value of 1 here, value 1 here, 1 over 2, 1 over 3. That was our exponent rule that we used back in the algebra world. Okay, and it's so in a dx here at the end. So we know that's our differential. It tells us basically it tells us what variable we're going to use and apply that rule to over here. So when we're going to take the antiderivative, what I would suggest that you do, this is what people tend to do, okay, you sit there and they do a +1 in there, and if I'm going too fast, just hit your pause button and you can catch up and it'll be okay. I won't continue on until you hit the go button again. Okay, so we're going to add 1 to this. So we have x to the 1 1/2, which is x to the 3/2. Whoopsie, it's a funny looking 2. X to the 3/2 power. And then we're going to take our 3 and divide it into our 3/2, or divided by 3/2. So we have 3 divided by 3/2. And the same thing here. I'm going to add 1 here. So that's going to give me x to the 4/3. X to the 4/3. And then we have 2 divided by the 4/3. And then don't forget your plus c at the end. The most stringent part of this is trying to work through this a little bit and do simplification. I think we're okay with applying the exponent rule to this. This we have to simplify. This is 3 divided by 3/2, which is 3 times 2/3, which comes down to a value of 2. This is x to the 3/2, which is x to the first times x to the 1/2. So we have x square root of x when we simplify the radical, minus, let's see, 2 divided by 4/3, which is 2 times 4/3, or 3/4. The 2 and the 4 will cancel to give me 3/2 here. This will be x to the 1, x to the 1/3, x to the 1 1/3 power. So we have x cube root of x plus c. Once again, today what we'll do is we'll determine what that value of c is. Well, if we look at this, it looks like, gosh, we need to have some sort of quotient rule. Some sort of quotient rule that will allow me to be able to calculate this. Well, we don't need a quotient rule, but we can rewrite this as each one of these is over the value of t to the 4th. So we have 3t to the 4th over t to the 4th minus t cubed over t to the 4th plus 6 over t squared. I'm sorry. Let's take that back a step. I did some simplification there. It's 6t squared over t to the 4th. So I can separate them into their own little fractions. So if I do some simplification here, this turns into 3 minus 1 over t plus 6 over t squared. And we're asking to take the antiderivative. Now if you look at it, I treated my differential to dt because my t is my variable I'm going to want to use my exponent rule for. So we have to take our antiderivative. If you remember what we talked about yesterday, if I take the antiderivative of a constant, or if I wanted to, I could take the write just the antiderivative of each one. If I take the antiderivative of my constant, dt, minus the antiderivative of 1 over t, dt, plus the antiderivative of 6t to the negative second, dt. I wrote it this so I can use my exponent rule. If you take the antiderivative of a constant, if you remember what we came up with yesterday, this is 3t. Because the antiderivative of a constant gives me more rather than take it away to 0 like the derivatives did. Now if you remember back why I didn't change this, what's the antiderivative of 1 over t? From yesterday that came down to negative ln of t. And then over here we're going to add 1. So my new exponent is a value of t to the negative first. And then we're going to take 6 and divide by that new exponent. And don't forget your plus c. This I still need to simplify. This comes down to negative 6. This gives me over t. So we have 3t minus ln of t minus 6, or plus a negative 6. It does not matter how you write that. You can go plus a negative 6, or you can just go minus 6 over t plus the value of c. And that's my antiderivative, or my indefinite integral. Those are 2 problems from your notes. Once again, if you have questions from your notes, feel free to email me your questions. I will highlight them on my videos the next day. Once again, if I'm going too fast, hit the pause button, slow me down. Well, what we're going to learn today is we're going to look at how do we find that c. And all the indefinite integrals, we have a plus c. Okay, we cannot find the c unless we have an initial condition in regards to the function. And that's what we'll go through today. Okay, this technique is called separation of variables. The separation of variables. I have dy dx is equal to x over y. Well, This is my derivative of y with respect to x, and if I take the derivative of that, I come down to y. But how do I deal with the other side? That's the problem we run into. So that's where we come up with what is called separation of variables. I want to get the x's with the dx and the y's with the dy's. So we just have a proportion here. So we can cross multiply. So we're left with y dy is equal to x dx. Now, just like we do everything in mathematics, we have equation signs here. We have an equality sign. And what we talk about is whatever you do to one side of the equal side, you must do to the other. Well, since we have these differentials here, how we get rid of those differentials is by taking the antiderivative of both sides, or the integral of both sides. So we have the antiderivative of y dy is equal to the antiderivative of x dx. So using our properties now, once again, this is 1. If we have ax to the nth dx, we have x to the n plus 1, and then a over the n plus 1 plus c. So if I separate these variables, I can take the antiderivative of both sides. Once again, hence the title, the separation of the variables. Okay, the x's don't get along with the y's. Okay, they've been cooped up in the house too long together. They're starting to fight a little bit. Okay, so we have to separate them, put them in their own little rooms. So now we can take the integral and we can calm them both down. So using my exponent rule, I'm going to come down to a y plus 1, so we have a y squared, and taking my coefficient of 1 dividing by 2 plus the value of c. And on the other side, it's going to look the same. Plus 1, my coefficient is 1, so I have x squared. And then we have 1/2 out the front plus, well, if I use c there, I can use maybe c1 or I could use d. It does not really matter. I'm just going to put another letter in there. So what we are left with, if I get all my variables on one side and all the constants on the other, remember that's the idea of a conic section, okay? I'm going to subtract 1/2 y squared and subtract d. So we're left with c minus d is equal to 1/2 x squared minus 1/2 y squared. Now, it's sort of ugly having those 2's in there. So we can multiply both sides by 2. So we are left with x squared minus y squared is equal to 2 times c minus d. Well, these are constants that we have no idea what they are. They're just constants. So if I take a constant and subtract off another constant, I get just another constant. Well, if I multiply that constant by a value 2, I just get another constant. So I just get a different constant there. Okay, we're not subtracting infinity minus infinity like we had with L'Hopital's rule, the indefinite rule, or the indefinite indeterminate form. Okay, we're taking some constant, subtract off another constant. We don't know what we're going to get. We're just going to get another constant. We multiply that other constant by 2. We're still going to get just another constant. If this is 5 minus 2, that gives me 3. Times 2, I get 6, another constant. We don't know what they are. So what we're able to do with this is just say, oh, you know what, rather than tag all this around, we can either just say, well, we just have another constant here is equal to x squared minus y squared. Now this c is probably going to be different than that c. That's okay. We just need to have representation that it's a constant there. So this is separation of variables. Now we can't find the c value unless we know a specific point that these go through. What this is, if you remember back to your fond memories of conic section back in pre-calc class, this is a hyperbola. This is a hyperbola. And what this is called here is this gives me a family of curves. This is a family of curves. X squared minus y squared, whatever my constant is going to give me a different graph. If this was 1, it's going to give me a graph. If this is 2, it's going to give me a different graph. This is 3, it's going to give me a different graph. They're all going to look very similar to each other, but they're not going to be exactly the same. It depends on this constant. So we get what is called a family of curves. A family of curves. Well, the question is, how do we find this C value? Okay, we've talked about the C value. Well, what we need to have is an initial condition to be able to calculate the C value. Here we have dy dx is equal to 3x squared plus 6x minus 7. Let's separate our variables. So let's multiply both sides by dx. So we're left with dy is equal to 3x squared plus 6x minus 7 dx. To get rid of these differentials, we can take the antiderivative or the indefinite integral of this. Well, my coefficient here is just a value of 1. I have 1 dy. So if I take the antiderivative, I have no y value there. It's a derivative of a constant. What's going to happen over here is this is just going to give me y. Y to the first power, because it's 1y to the 0th power. Okay, let's watch the magic that we're doing here. Okay, we have 1y to the 0th power. I'm going to add 1 to this, because it's going to give me y to the 1th. And I'm going to take 1 and divide by 1, so I get this y to the first. On the right-hand side, it's a little bit different story. I'm going to add 1, and this is going to turn out nicely for us. So my new exponent is going to be x cubed. I'm going to take 3 and divide it by 3. I have a 1 here plus 6. I'm going to add 1. I shouldn't have done that. I'm going to get an x squared, and I'm going to take my 6 and divide by 2. Minus 7, antiderivative of a constant, once again, is going to be the constant x times x, just like this just turned into y, plus this value of c. So simplifying this, we have y is equal to x cubed plus 3x squared minus 7x plus c. Now this is where we use our initial condition. We know this graph goes through the ordered pair 1, 7. This tells me here I have an ordered pair of 1 and 7. So my x value is a value of 1. My y value turns into a 7. So down here, we can make some substitutions. Y is a value of 7. This is equal to my x value, which is 1 to the 3rd, plus 3 times 1 squared, minus 7 times 1, plus c. So now we have a little equation that we can use to solve for c. So we have 7 equals 1 plus 3 minus 7 plus c. Adding your 7 over and subtracting your 4 over, we get a c value of a value of hopefully 10. Adding 7, that gives me 14. Subtract off your 1 and 3, subtract off 4, I get a c value of 10. So with this initial condition, y is going to equal to, and this is what you need to make sure you go back and do then, x cubed plus 3x squared minus 7x plus 10. There's many forms to differential equations. This is just one form of a differential equation. We will keep it very basic right now. When you get to college, if you go through the calc series in college, your calc 4 in some schools is also called differential equations in a second school. Basically, all you do for an entire semester is solve different types of differential equations. Okay, this is just one example of a differential equation. Okay, take a look at another one. Let's separate our variables. So we have multiplying by dx, dy is equal to 5e to the x dx. Okay, separating our variables. Taking our antiderivative, both sides. We have y is equal to 5. Well, antiderivative of e to the x. Well, let's think about this. When I took the derivative of e to the x, what did we get? That's correct, an e to the x. So if I take the antiderivative of e to the x, what do you think we get? You're exactly correct, e to the x. So we're just left with 5e to the x plus c. We have to find the value of c. We know our function value at the ln of 4 is 20. So we have 20 is equal to 5 e to the ln of 4 plus c. E to the ln of 4 is the value of 4 plus c. So we have 20 here. If we subtract 20 from both sides, our c value comes down to a value of 0. So what this turns into is y is equal to 5e to the x, because we have a plus 0 there. Okay, what I want you to do is I want you to work on this one here. Okay, work on this one here. What I want you to do is turn off your video, turn it off, work the problem out, see what you come up with. I will work the problem back, so work the problem out also. Turn the video back on, see if you come down to the exact same thing. I'm not going to pause and wait because I want to try to shorten the length of the video. So you pause it, shut me up, okay? Go back on when you're complete, see if you got the correct answer. Separating our variables, y dy is equal to x dx. Okay, and this looks very similar to what we did up above. Antiderivative, antiderivative. We have 1 and 1, so we have 1/2 y squared plus c is equal to 1/2 x squared plus d. If you remember what we did up top, we have c minus d is equal to 1/2 x squared minus 1/2 y squared. We multiplied through by 2. So we're left with, when we do all this put together, some constant c is equal to x squared minus y squared. My x is a value of 4. My y is a value of 25. So we have c is equal to 4 squared plus 25 squared. This gives me 16 plus 625. So we have c is equal to 641. So x squared plus y squared, or minus y squared, is equal to 641. Again, just technique of solving differential equations. Okay, this is the last of the new material of the chapter. Okay, from this point on, the next few days, we will be looking to review just the concepts that we've talked about. We had Newton's method. Okay, we had yesterday indefinite integrals, and also today we had differential equations. So expect some worksheets in regards to indefinite integrals and just some extra practice with it, and Newton's method, and we'll work on looking at getting to a quiz sometime in the middle of next week. Hopefully we can get a chapter test on chapter 4 at the end of next week. So early at the beginning of the week we'll look to get a quiz over this, and then we'll get a review, and then we'll get a chapter test over the entire chapter 4, and that will take us right up to spring break then. Hopefully, once again, everything's going well at your household, you're staying safe, keep your social distancing. If you have any questions, feel free to email me any of the questions or make comments on YouTube, or not on YouTube, on the on Google Classroom. Make some comments on there, and I'll get back to them as quickly as possible. If there's nothing else, please do keep your social distancing. I hope everybody has a good day. Hopefully the weather will turn nice here and we can get outside and breathe some fresh air outside a little bit. I hope it's all going well for you. Once again, I miss not seeing you guys on a daily basis. This is the best we can do. You folks have a good day. Adios.